Hello students, in this video let's start the chapter 3 of statistics, multiple regression. Multiple and partial correlation. This is our chapter here. So what it says, a study related to joint effect of a group of variables on a variable not included in that group. On a variable not included in that group is of multiple correlation and multiple regressions. Okay, now suppose x1i, let it be x1i, x2i, x3i, such that I from 1 to n form trivariate sample data, the means of these variables for the given sample R denoted by x1 bar, x2 bar and x3 bar respectively. They are denoted by this capital X1 bar, x2 bar, x3 bar respectively. Again, let small x1 will be capital X1 minus x1 bar. x2 will be capital X2 minus x2 bar. And x3 will be capital X3 minus x3 bar. Okay. Now, as the sum of deviations of the values in the data from its mean is 0. So it says this x1, this gives summation x1, summation x2 and summation x3. These are nothing but deviations about their mean. So as the sum of deviations of the values from its mean is what? 0. Means these sums of these one are what? 0. And that gives then x1 bar, x2 bar, mean of these deviations are also then what? 0. If the sums are 0, then their means are also 0. And summation x1 square is nothing but n sigma 1 square. Summation x2 square is nothing but n sigma 2 square. And summation x3 square will be n sigma 3 square, right? Also, covariance between x1 and x2 is what? Summation x1 x2 upon what? N, right? And correlation coefficient between x1 and x2 will be denoted by R12, okay? R12, and that will be covariance between x1 x2 upon sigma 1 into sigma 2. You know that part. Therefore, from this, summation xi xj will be what? N covariance between xi xj. From this result we can write summation x1 x2 will be n into this covariance. We can take this n to this side, right? And from this result we get the summation xi xj. Here I can put the value of this covariance, this one here. Then using that we get n into rij sigma I into sigma j. This is the result for that, right? Where I not equal to j and ij are running from what? 1 to 3 now. Here 3 variables are there. So 1 to 3. Trivariate data is that, right? Where this rij, what it is the, where the rij is the total correlation coefficient between xi xj, is the total correlation coefficient between xi xj. Now let's see the multiple regression. The study of multiple regression multiple correlation coefficient and partial correlation coefficient. Using the matrix of correlation coefficient. Using the matrix of correlation coefficient becomes simple. The matrix of correlation coefficient matrix of correlation coefficient is denoted by R and is given by this R is equal to the matrix of Rij. What does it where this Rij is nothing but correlation between Xi and Xj, where Ij are what? 1, 2 and 3. Trivariate data is that. That's why Rij will be these one. Therefore, what is R? R is nothing but the matrix. What? R11, R12, R13, R21, R22, R23, R31, R32, R33. But as we know that correlation between the same variable is what? 1. So as these R11, R22 and R33 will become what? 1. And also correlation between x1, x2 is same as correlation between x2, x1. So due to that, R12 is same as R21, R13 is same as R31 and R23 is same as what? R32. These are same. Therefore, what does R then? Then R is equal to what? It will be 1 R12, R13, then R21, 1 R23, then R31, R32 and what? 1. Right? Again, let Rij equal to what? Cofactor of element Rij in this determinant of R. Okay. Therefore, cofactor means what? Rij is nothing but minus 1 raised to I plus j into minor of this entry Rij, right? Minor of this correlation coefficient. Fine. So let's determine all the values of all the cofactors of all the elements. Okay. So let's see that. So we have to determine all cofactors. So let me start from R11. What is R11? It will be minus 1 raised to 1 plus 1 into minor of R11. R11 is this. So minor will be these entries 1, R23, R32 and 1. This is it. So it will become 1. So it is 1 minus R23 square. Right? Then now what about R12? R12 is what? Minus 1 raised to 1 plus 3. Determinant of whom? It will be determinant of R21, R23, then R31 and R33. That is what? 1. Right? It will be 1. So this is R minus R21 minus R31 R23. Okay. So it is same as to write what? R23 R31 minus R21. Okay. Then next R13. R13 will be minus 1 raised to 1 plus 3. Sorry, here 1 plus 2 is there, right? 1 plus 3. What is the determinant or the minor of R13 will be R21 1, then R31 and R32. Okay. So it will be what? R21 R32 minus R31. Okay. Then next R22 is what? Minus 1 raised to 2 plus 2. Determinant of what? 1 R13 R31 1. So it is 1 minus R13 square. Then R23 add what? Minus 1 raised to 2 plus 3. So it is 1 R12 R31 and R32. Right? That is same as minus of R23 minus R12 R31 equal to R12 R31 minus R23. Okay. And one more R33 we need to find out. Okay. So minus 1 raised to 3 plus 3. Determinant of what? 1 R12, then R21 and 1. So that will be 1 minus R12 square. So now these are the cofactors. Now let me write few notes on these cofactors. Note. So 1, Rij is equal to Rgi for I not equal to j. Okay. Second says determinant of R will be this R11 into cofactor of it plus R12 into its cofactor plus R13 into its cofactor. Okay. So this will give us, after simplifying, it will give us 1 minus R12 square minus R13 square minus R23 square plus 2 R12, R13 and R23. This is a result for it. Third thing, it is important, the question will ask on this one mark question. The condition for consistency of the given total correlation coefficient. It is given as determinant of R will be what? Greater equal 0. Either 0 or positive, but won't be negative. Then the data will be consistent for total correlation coefficient, for the given total correlation coefficient. Okay. So that is same as R12 square plus R13 square plus R23 square minus 2 R12, R13, R23 will be what? Less equal 1. Now let me give one example to you for this. For a trivariate data, what are the values given? R12 given 0.75, R13 is given minus 0.8 and R23 is given 0.9. So are these values consistent? This is a question. So for this we will use this third note. This third note we are using for this, so you can check it whether it is consistent or not. You find out this value, that value should be what? Less equal 1. All these are given us, right? Now next thing we have to see Euler's notation. It is about the lines of regression. Okay, let's see that. Euler's notation. What does it? Let x1, x2, x3 be 3 related variables. Be 3 related variables given a sample of n observations, given a sample of n observations on the variables x1, x2, x3, where the ith observation is given by, where the ith observation is given by x1i, x2i, x3i, is triplet of values, okay. Now the regression of this x1 on x2 and x3 is the multiple regression. Is the multiple regression. The linear equation joining these 3 variables, in 3-dimensional space, in 3D space, represents a plane called the plane of regression. Now let x1 be dependent variable, and x2, x3 be independent. Regression of x1 on x2, x3, we had assumed x1 will be dependent and x2, x3 are independent variables. And let the equation of and let the equation of plane of regression of x1 on x2 and x3 is x1 equal to a plus b x2 plus c x3. Call it as equation number 1. Okay. Here, since there are 3 variables, so there will be 3 such a regression equations. In order to differentiate the regression equation, Professor Ch3v1 Euler has introduced a set of notations. According to him, according to Euler, the coefficients which coefficients? This B and C. The coefficients B and C in equation 1 are to be replaced by B123 and B132 respectively. Now here we had given just one equation where x1 is represented in terms of x2, x3. Other one we can write x2 is represented in terms of x1, x3, and x3 can be represented in terms of x1, x2. These are these 3 equations in 3 variables. Okay, so such 3 equations of plane of regression we can write. And what are the coefficients? These B and C are nothing but B12.3. What are they? You can show it. Okay, so now due to that, equation 1 becomes x1 equal to a plus B12.3 x2 plus B13.2 x3. Call it as equation number 2 now. Okay, where the constants B12.3 and B13.2 are known as are known as the partial correlation, partial regression equation. Sorry, not a correlation, partial regression coefficient. Of x1 on x3 and x2 respectively. X1 on, sorry, here x2 and x3 respectively. Okay. Also here let me tell you, also this B12.3, here this 12 is nothing but a primary subscript. And this 3 is what? Secondary subscript. This dot or this primary subscript and secondary subscript are separated by what? Dot, right? That is what? Dot. Okay. Now again B12.3, here this 1 is nothing but dependent variable. It is dependent variable. This 2 is independent variable. And this 3 is what? The remaining independent variable in that equation. Okay. Now for example, B12.3, in this one, x1 is what? Dependent variable. While what is x3 or x2, simply x2 is what? An independent variable. X2 is independent variable. Okay. So here we will stop. In next video we will see fitting of regression plane, also interpretation of regression coefficient, then multiple correlation, partial correlation coefficient. Thank you.